Okay, so what I'm saying, to define what a normal salt is, the only difference is where there is there here in the first definition. Here, where there is there, here you are going to put the word O. Okay? So look at the difference. Normal salt, this is a salt formed when O, the hydrogen ions, in an acid are replaced by a metal or ammonium ions. To understand what I'm talking about, go to here. When we talk of another type of salts, which is acid salt, again you find that this is a salt formed when part of, instead of O, instead of there, or instead of O, there is part of. Have you seen that? This is a salt formed when part of the hydrogen ions in an acid are replaced by a metal or ammonium what? Ions. Examples are here, where it says O hydrogen. Look at where it says O hydrogen. You can see here, sodium hydroxide reacted with this acid HCl. Find that there's no hydrogen that is remaining in this salt formed. Okay, which means all the hydrogen have been displaced to form water here and a salt. Have you seen it? But here, look at this example. This is an acid salt. Potassium hydroxide reacted with sulfuric acid here. There is hydrogen remaining. This is the potassium hydrogen sulfate. So, by having this hydrogen here, it means not all the hydrogen have been replaced. It is only part of hydrogen. So, as long as this hydrogen is there, it's the one that causes acidic nature of this salt. So, as long as hydrogen is here, this salt is an acid salt. But this one, is there any hydrogen? Is there any hydrogen here? All the hydrogen ions in an acid are replaced by a metal or ammonium ions in a normal salt. But in an acid salt, this is a salt formed when part of the hydrogen ions in an acid are replaced by a metal or ammonium ion. Examples are here. You can see the hydrogen remaining in this. Have you seen that? This is ammonium hydrogen sulfate, calcium hydrogen carbonate. All these are acid salts, where not all the hydrogen ions are displaced, only part of it. Have you seen? Okay, don't confuse yourselves. Next, we are going to look at the solubility of salts. Solubility of salts we are talking about is just a revision. In fact, we have already done this one several times. Solubility of salts. Solubility is the ability of a salt to dissolve in water. If a salt is able to dissolve in water, then it's soluble. We are talking about that ability for it to dissolve in water is what we call solubility. So solubility rules are as follows. I told you that all nitrates are soluble. Then all chlorides are soluble. All sulfates are soluble. And then carbonates, there are only 3 carbonates that are soluble: sodium, potassium, and ammonium. But be careful here when we say all chlorides are soluble. Not all of them, but there is an exception. We say all chlorides are soluble except silver chloride and lead chloride. So to remember the insoluble chlorides, you use this mnemonic, Sile or Sil. Then this one stands for silver, this one for lead. Same applies here, all sulfates except barium sulfate and lead sulfate are soluble. So think of that player Bale. You know, you guys who watched Tottenham so much. There was a player called Bale. Also, he played for Real Madrid. Bale. At least this mnemonic can help you remember. It can help you remember the sulfates that are insoluble. Then all carbonates are insoluble, except these are the only ones that are soluble in water. Okay?